All right, so in box number 27, we have the definition of a midsegment. A midsegment is the segment that connects the midpoint of two sides of a polygon. So let me just draw a little example for you guys. If you had a triangle, here is a triangle. Actually, let me just draw a weirder triangle. Okay, just imagine that's a straight line, okay? That's a straight line, straight line, straight line. Here's a triangle. All three sides are different lengths. So if I wanted to draw a midsection, I would find the midpoint of two of the sides, and I would connect them. Okay? So that's a midsegment. The blue thing is a midsegment. The midsegments of adjacent sides creates a parallelogram. So that is the midsegment of, okay, that has to do with a quadrilateral. So let me draw a quadrilateral for you now. Just some random four-sided shape. And I'm trying to make it as weird as possible so it doesn't look like a square or a rectangle or anything. Here you go. Here's a weird four-sided shape. Looks kind of like a shoe, huh? Okay, so we're going to create our four mid-segments. So connect the midpoint of here to here. Actually, let me just draw all the midpoints first. Okay, roughly looks like that. Zoom in so I can connect them better. If you connect all four midpoints of a quadrilateral, look at my blue shape that I just made. That blue shape is a parallelogram. So if you have four mid-segments of a parallelogram, four mid-segments of a quadrilateral, you will create a parallelogram. That's what this bottom thing is saying. Okay, so I tripped over my words several times there. Do you guys have any questions on that? All right, if not.
No.
Okay, thank you. If not, then let's read a conditional statement. A conditional statement is a statement that can be written as if, then. So for example, if you are smiling, then you are happy. That is a conditional statement. Or if you are frowning, then you are sad. Something like that. Those would be conditional statements. Give me one moment while I mark the attendance because somebody just came in. Okay, next, let's talk about hypothesis and conclusion. Oh wait, okay, somebody said, what did I just say? Okay, I was reading you the definition of conditional statement. A conditional statement is a statement that can be written as an if-then statement. So for example, if you are smiling, then you are happy. If I am thirsty, then I drink water. Something like that. So if something, then something else. That is a conditional statement. Then for a hypothesis, that's the part of the conditional statements after the if. So in our original example, let me do some highlighting here. It is the if you are smiling, so it's this part. The hypothesis is the yellow part that I just highlighted right over here. In contrast, we have the conclusion. It's the part that comes after the word then. So conclusion, you are happy. So if hypothesis, then conclusion. So all the conclusions I have put in purple. If hypothesis, then conclusion. All right, let's go to the next one. For number 30, box number 30, I mean, we have a converse. A converse is a conditional with the hypothesis and conclusion switched around. So the converse, you can just remember it. Here's something that maybe can help you remember. Converse starts with CO, and that C can stand for change, and the O can stand for order. So you change the order. So for example, if it says if P then Q, then you switch it. If Q, then P. So if we were to write the converse of our original example, here's the original example. If we're writing the converse for that, I would write if you are happy. Why is my handwriting so bad? I'm so sorry. If you are happy, then you are smiling. So all we did is switch the order of the hypothesis and the conclusion. You just switch it around. Do you guys have any questions on this? Okay, so somebody's...
Wait, can you say that part one more time?
I couldn't understand what you said. I'm sorry. I think the internet's really bad. Can you say it again?
Can you say that last part one more time?
Okay. So I took our original example, which is right over here, about the if you are smiling, then you are happy. That was our original conditional statement. So what we do when we write the converse is you flip it around. So instead of if you are smiling, then you are happy, I wrote if you are happy, then you are smiling. So you change the order of it. So I put the purple first now, so let me highlight. If you are happy, then you are smiling. See, in our original over here, I'm trying to point, original one over here, we have if yellow, then purple. Now we have if purple, then yellow. If you are happy, then you are smiling. So I switch it around. And then somebody else says they don't understand the conditional statement. So it's literally any statement that you can write with if and then. So I can give you more examples. Like if I am sleepy, then I go to bed. So this is a conditional statement because I have the word if something, and then I have the word then something. And then I could come up with another one. If I am hungry, then I eat. So this is also a conditional statement just because it has if and because it has then. So yes, all you have to say is if something, then something, and it is a conditional statement. That's all there is to it. Good question. Good. So I'm glad that you're asking questions. That means, you're going to understand it better. And also, if you're asking, that means someone else has that same question too. They just were too shy to ask. So if you have a question, don't be shy. Just make sure you tell me. All right, let's go to number 31, biconditional if and only if. So a biconditional statement is a conditional statement is true and its converse is also true. So I know it looks confusing over here, so I'm gonna give you an example of one later. So conditional statement says if P then Q, right? Converse is just a changed order of that, if Q then P. Biconditional is if P happens if and only if Q happens, or Q happens if and only if P happens. So let me give you an example of a biconditional statement. I'm going to zoom in just so I have space to write. So let me give you the conditional. If a polygon has 3 sides, then it is a triangle. Oh no, I ran out of space. Okay, here's a conditional statement. If a polygon has 3 sides, then it is a triangle. And then the converse of that would be if a polygon, instead of having 3 sides, I would write is a triangle, then it has 3 sides. So both of these statements, they are true, because by definition, a triangle is a polygon with 3 sides. So if a polygon has 3 sides, then it is a triangle by definition. So if a polygon is a triangle, then it has 3 sides by definition. So when you write your biconditional, which I will write in blue because then everything doesn't have to blend together. For our biconditional, a polygon, has 3 sides if and only if it is a triangle. Okay? You can also write it the other way, but I don't have space, so I'm not going to. The point of a polygon is that you write if and only if, I'm going to highlight that, if and only if, you write that part because both the conditional and the converse are true. Okay, do you guys have questions on this one? Could be slightly confusing, right? Okay, so maybe as we do more examples, you might come up with more questions, but for now, these are the notes, and once we do more examples, okay, sorry. So somebody glitched. I know the internet's really bad, so let me repeat it again. Biconditional, a version of what we were saying over here, is a polygon has 3 sides if and only if it is a triangle. So when you write your biconditional statement, you write the if and only if, the part that I highlighted in yellow. You write that. And you write that because both the conditional and the converse were true. Yes, this will be posted in the, well, not in the classroom, it will be posted on the website. But the link to the website is in the classroom. I can't talk. Okay. So you guys can rewatch this as many times as you need to in order to, understand. By the way, I want to I want to warn you that this is the last page of our notes. So that means the test is coming up soon. It's not this week, it's next week on Thursday. Next week on Thursday is the planned date for the test for this topic. So these 3 pages of notes, you can use it on the test, okay? All right, let's go to a right triangle. I think this is just review for you guys. Here is a picture of a right triangle. A right triangle has a right angle on one of the corners, and it has to be just one of the corners. So here they note the right angle with the red square that they kind of draw in, just to remind you that this is 90 degrees. Okay, so a right angle is 90 degrees. And then that leaves the other 2 angles to be acute. That means less than 90 degrees. So both of those smaller angles, they are less than 90 degrees. And on your right triangle, the 2 shorter sides are going to be called your legs. So that describes this side and this side. These are your legs. And the long side is called the hypotenuse. That's this one. That's called your hypotenuse. And that's how you spell it. Any questions on the right triangle? Okay, let's go on to right triangle rules. I'm going to zoom out like that so you can look at it. For a right triangle, all right angles are congruent. That's just about right angles in general because all right angles are at 90 degrees. So if all those right angles are all 90 degrees, then they're all equal because they're all 90 degrees. So they're all congruent. That's why all right angles are congruent. And then another note or another point is the acute angles of a right triangle are complementary. So let me label those. Let's call this one A. Let's call this one B. Those are your two acute angles. So measure of angle A plus the measure of angle B, they're going to be complementary, so that means they add up to be 90 degrees. If you guys forget what complementary means, it's in these notes. You just have to scroll up a little bit. Okay, it tells you that complementary means you add up to 90 degrees. Do you guys have any questions? Okay. If you do, feel free to interrupt me. Let's go on to an isosceles triangle. An isosceles triangle, here's a picture of it. The thing that makes an isosceles triangle an isosceles. Okay, so hold on. Let me check the chat. I think I sent this here, and somebody's gonna join again later. Okay, that's fine. Okay, so isosceles triangle. It has the two of the sides where they're the same length. That's what this little mark means right here. So I drew one mark through each of those sides to say that those two are equal. Because both of those sides have one mark, it means they're equal. However, for the base, I can draw two marks because it's not equal. I can also draw 3 or 4, but why waste your time drawing so many marks? You can just do one mark for the equal sides and then 2 marks for the other one. Okay, and then also the base angles, those two red angles, they are the same measure, so they are congruent. The base angles are congruent. And then that top one is called the vertex angle. So similarly, you can draw little marks, but I'll draw 2 there to say it's not equal to the base angles. Let's scroll out. I believe there should be, yeah, I guess we have to just keep it scrolled out so we can read the isosceles triangle theorem. Okay, so box number 35, if two sides of a triangle are congruent, then the angles across from those are congruent. So what that means is, if you're looking at the box number 34 again, we said the two legs are congruent. So that means the angle across from it, let me use a different color. I'll use purple. The angle across from it, so that base angle, is congruent to that base angle. We already talked about it. Those two base angles are congruent. And you can read the next one. It says the base angles of an isosceles triangle are congruent. We just said that again. All right. Questions on isosceles? All right, let's do equilateral. Equilateral is the most perfect triangle. So it has 3 equal sides and 3 equal angles. So equilateral means 3 equal sides. Equiangular, I really don't know how to say that most of the time. Equiangular is 3 equal angles. That's why you can see the word angular right there to represent angles. Equiangular. Say it however you want, I don't care. Okay, 37, congruent equal measures. So it sounds like you guys already know about this, but if angle A is congruent to angle B, then measure of angle A is equal to measure of angle B. Let me zoom in. So this is the congruent symbol. Okay, so if line segment AB is congruent to line segment LM, then AB's length is the same, is equal to LM's length. Okay, any questions about those two boxes? Alrighty, let's. I hear someone really quietly. Okay, I don't think I'll be able to hear your voice. Could you type it in the chat? I'll wait for you. It was really hard to understand.
Can you hear me, Ms. Jen?
Barely, but a little bit, yes. $37. Oh, okay, so 37. Let's go over 37 again. So for 37, it's just talking about, it's just giving you the definition of congruent. So congruent means it has equal measures. So for example, if you're talking about angles in this first line, if angle A is congruent to, that's the symbol for congruent. It's got a squiggly and then equal sign. If angle A is congruent to angle B, then the measure of angle A is equal to measure of angle B because they have equal measures. So measure of angle A is equal to measure of angle B. Then on the bottom one, okay, if line segment AB is congruent to line segment LM, then the length of AB is equal to the length of LM. So that's what it says. It's just saying, I think most of you guys already knew this before. It's just writing it out again for you guys, just in case you guys might need it for the test if you forget, if you blank on it. Okay. Let's do 38. All right, exterior angle is an angle created by extending the side of a triangle. And a remote interior angle is an interior angle not adjacent to the exterior angle. So, for example, if we took this side and we extended it outwards, then we have over here, the EXT, that is your external angle. So that is your exterior angle. My bad. Exterior angle. And then, since the exterior angle was extended off of this C, then the other angles, the A and the B, put it in a different color. These are your remote interior angles. So it's the one that's not directly next to your exterior angle. Any questions on that one? Okay, let's go on. Exterior angle theorem. Okay, they have another picture so I can zoom in. So box number 39, exterior angle theorem. The sum of remote interior angles equals the exterior angles. So let me do this. I guess I'll use measure of angle ABC. That's this one, ABC, so it's this angle. This angle plus the measure of angle BCA, so BCA, so this one. If you add it together, I picked blue and yellow so I could use green for this one. You'll get the measure of angle DAC. So blue plus yellow equals green. So those two remote interior angles, when you add them together, it gives you the exterior angle. Do you guys have questions on that? Okay. So let's go on then. Make sure you do interrupt me if you have questions. Triangle inequality theorem. So this says the sum of any two sides of a triangle must be greater than the third side of the triangle. So you cannot have a triangle where like this side, oh, that's really That's a really thick line. Give me a second. Let's give these side lengths a measurement just so that you can visualize it some more. This one, let's say that looks like a 5 to me. Like, let's just say that's 5 long. This one looks like it's maybe 4 long. It's a little bit shorter. And this one looks like a 13 to me. So you cannot make a triangle out of these 3 side lengths because 5 plus 4 is not long enough to cover 13. So the sum of any 2 sides of a triangle must be greater than the third side of the triangle in order for the triangle to work. You need, let's call this one A, B, and C. You need A plus B to be greater than C in order for the triangle to work. Now, if we were in class together, I have all these ideas on how I would have like shown this to you, the popsicle sticks and stuff, but we're not in class together, and I'm so sorry. So you just have to take notes on this and just look at it. I'm sorry. Do you guys have questions? No? Okay. Let's go to the next one, mid-segments of a triangle. So we already talked about a mid-segment being the connection point of the midpoints. So it connects the midpoints of 2 sides of a triangle. So if AB, you find your midpoint M. AC, you find the midpoint N, and you connect it. That is a mid-segment. That's the first thing we talked about in today's notes. So MN, connecting M and N, that is your mid-segment in triangle ABC. That is one of the mid-segments that you have. So the rules that apply to mid-segments is that your mid-segment is parallel to the third side. Let me highlight that third side. So we put a midpoint on AB. So we're not talking about this line. We put a midpoint on AC. We're not talking about this line anymore. The third side that we are talking about is BC. So that's the third side. So your MN, your mid-segment, I'll put it in blue. Your blue line is parallel to your green line. Your MN is parallel to BC. Okay. Do you guys have any questions about that one? No, you're just like, get on with it, Miss J, you're taking too long. Okay, so then also the length of the mid-segment is half the length of the third side. So once again, MN, the blue line, is half the length of BC, the green line. So, and I know it's a little bit hard to tell from just the picture, but if you were to take a ruler and measure it, you will find that it is half the length, okay? Do you guys have any questions on that? No? Yes. Okay, I see some shaking heads. I guess not. All right, I'm going to stop the recording.